Hey guys, today we're going to learn about the concept of power. Power really is nothing much more than energy per time, whether that be potential energy per time, or kinetic energy per time, or even something like heat per time, right? Something like that. Any of those various things, that's what power is going to be related to. So a lot of the time you'll see it for things like energy use or energy production. But for that matter, it could just as easily be for something like how much work is done in a given amount of time by something like an elevator. So the unit for power is the watt, which is a joule per second. All right. So if we put that into the context of, oh, I don't know, something like gravitational potential energy, I know this is going way back here. Well, if you have something like, say, an elevator that lifts you up a particular height in a given amount of time, the power of that elevator would correspond to the rate at which your potential energy changes, which might be something like, well, if I take height divided by time, that would be, say, your upwards velocity. Okay, or it could be something where you're talking about, say, the rate of change in the kinetic energy of a car. Okay, and so that would be very appropriate for, say, talking about like a sports car, right? How much horsepower does it have? Well, that's going to correspond to the rate at which its kinetic energy changes versus time. Now, the symbol I'm going to use for energy for the rest of this presentation is going to be U, really for no particular reason. I could have used any of the others like kinetic energy or heat, and it would have been just fine. Rearranging that equation, we get that U, or energy, is power times time, which should make sense to you since we said energy is measured in joules, and since power is, it could be measured in watts, which is a joule per second. If I take a joule per second times a second, that gives me joules. But really, if I take any unit of power times any unit of time, it's going to give me a particular amount of energy. So you are probably at least somewhat familiar with the unit of horsepower. Now, what's a horsepower anyway? Well, apparently a British horsepower is this. I tried to look up what an American horsepower is since I've never heard it called anything other than just plain old horsepower. And apparently a British horsepower and American horsepower are the same thing. So I don't seem to think there's a distinction, unless I'm wrong. Excuse me if I am. All right, now a horsepower a day, it's a unit of power times a unit of time. That would be a particular amount of energy. I suppose it would correspond to the amount of work that a horse could do in one day, okay, or a 1 horsepower motor for that matter. All right, fine. But the point is that if you take a power unit times a time unit, you're going to get some amount of work or energy. So it doesn't matter what kind of a power unit you have and what kind of a time unit, it's going to be an amount of energy. Now, a much more common energy unit than the horsepower day, which frankly nobody uses horsepower days, is the kilowatt hour. Now, if you're thinking to yourself, kilowatt hours, I've never heard of this. Well, probably you have, but you may not have seen it before if you don't, say, pay the electric bill. Okay, so in terms of joules, which is a much more familiar unit to us, what exactly is a kilowatt hour? Well, a kilowatt is 1,000 watts. Okay, fine. An hour is 3,600 seconds, right? 60 seconds per minute, 60 minutes per hour. And since a watt is a joule per second, those seconds units are going to cancel, giving us, whoa, 3,600,000 joules? That's 1 kilowatt hour. So how big really is a kilowatt hour? I mean, in terms of your electrical consumption, a kilowatt hour is kind of not that big of a deal, all things considered. 3,600,000 joules of energy, though, is kind of a lot. If you had that much kinetic energy, I mean, wow, you would really be moving, okay? But you can understand maybe why they don't charge your bill from the electric company in joules. So here is a sample electric bill from the energy company. I just wanted you to see where the kilowatt hours is on there. So here we have current usage, right, from this hypothetical John J. customer. And let's see, over here we have the amount that he is being charged for, for using 453 kilowatt hours. And as you can see, the rate here is 13.588 cents per kilowatt hour. That's really not all that much money, all things considered. Really, electricity is incredibly cheap. So even though this guy used 453 kilowatt hours, it's not really an outrageous energy usage, and it's not actually all that expensive. Still, you could imagine that it would be rather alarming to have on your bill the number of joules of energy that you used, even if it was being billed at a very small rate. And of course, if it was 13.588 cents per joule, I think you would go bankrupt in very, very short order. Okay, now, where are we trying to get with all this? Well, what we're trying to get to is being able to work out a power-related question. So this is example 6 from your notes packet. How much energy is you? Okay, all right. So we're supposed to figure out the answer in 2 different units, kilowatt hours and joules. Now, the relevant numbers in that prompt were, of course, 400 watts for the heater, which is, of course, 400 joules per second, and 10 hours is the amount of time that it's being run for. All right, now, when I originally wrote this question, just for context, I didn't actually go and look at a space heater. Turns out a small space heater, such as you might use to, say, heat your bedroom, in the winter, is 1,500 watts. So this is not a very good heater. This is more like a coffee cup warmer or something. Well, maybe a little better than that. So I looked it up, and actually a microwave is 1,000 watts, and so is a toaster. So 400 watts is enough to heat something up, but probably not to raise the temperature of your bedroom very much, right? A microwave and a toaster are heating very small volumes, and so 1,000 watts is plenty to get your soup boiling in, a couple of minutes. All right, regardless of the reasonability of the numbers versus various appliances, the premise is we're trying to find the energy. And as we learned, energy is power times time. Now, it appears that I goofed when I made my slides, and I did these backwards. So this is actually part B that we're solving first. So 400 watts, that's 400 joules per second, times 10 hours is, not 3,600. That would be 1 hour. Had another 0 on there. Seconds. There we go. Okay, so 14,400,000 joules. Whew, that's a lot of joules. All right, now, just kind of for fun, how much energy is that anyway? Well, if this were, say, the kinetic energy of something like, I don't know, a car, throw that in there, then we would get a speed of 120 meters per second. Okay, I'll let you convert that to miles per hour, just for, perspective. When you start getting into the energy used by appliances, you do start to get some pretty crazy answers like this. All right, but that's just how it is. Heat energy, there's actually a lot more energy in heat than most people really think about, because you're talking about the kinetic energy of billions upon billions of tiny little molecules, as opposed to, the kinetic energy of like a sports car. Okay, but because there's so many of them, you're still talking about a lot of energy. Okay, and now part A, also known as the easy part, right? If you get kilowatt hours, you shouldn't be like, oh no, kilowatt hours. It's literally just this. Kilo's 1,000. So move the decimal point over 3 places, and now 400 watts becomes 0.4 kilowatts, and then leave hours alone if it's already in hours. If not, then you'd have to convert it. Okay. All right, you got to fix it. Extra there. Okay. And we would get 4 kilowatt hours. Okay. All right. So there you have it. So regardless of whether it's in joules or kilowatt hours or whatever, that's how you can calculate the energy given a amount of power and a period of time for which it is used. All right, hope that was helpful. Let me know if you got any questions, and I'll see you on the internet.